Today we'll be discussing sacromeres and sliding filament theory. Sacromeres are one of the parts of our bundle that make up myofibril. Myofibril bundled together makes our muscles. The sacromere is defined by the distance between two Z lines, and the M line, which runs down the middle in the orange, holds it all together. The two main components of a sacromere are actin in red and myosin in the middle. Actin is the thinner filament, myosin is the thicker filament. The length of a myosin is called an A band, also known as the dark band. It's the dark band because it's thicker and less light goes through. The I band is the distance between two myosin filaments, and it's called the I band because also the light band because light can pass through. And that is the structure, the basic structure of one sacromere. And now we move on to sliding filament theory. So sliding filament theory looks at how our muscles move, and it begins in the synaptic cleft and the axon terminal, wherein the vesicles release ACH into the synaptic cleft. The ACH binds to receptors that are attached to the sacromeres, causing the release of calcium. Oops, that's not calcium. Release of calcium. The release of calcium then moves into the actin filament, where it attaches to tropomyosin. The tropomyosin is attached to the actin binding site. The presence of calcium releases the tropomyosin and replaces tropomyosin with the molecule of troponin, which moves down the binding site of the actin to allow the sliding filament theory to occur. And our myosin head at the time is preoccupied with the molecule of ATP, which allows it to be free and not ready. But when the presence of calcium is there, ATP is hydrolyzed into a molecule of ADP and a free-floating phosphate, cocking back the myosin head. The myosin head then attaches to the active site, binding site of the actin, and then the ATP is released and our actin moves forward. Our myosin head is cocked back, and while the presence of calcium is still there, the process repeats. ADP is pulled back, attaches to the myosin head, and keeps moving it forward, or the actin head. The actin moving forward is all of our muscles collectively moving together to allow our body to move and jump around. And that's the sliding filament theory.